Welcome all. Next lecture, we are going to discuss about internal combustion engine vehicle, which are current portfolio vehicle what we use versus electric vehicle EVs, what we call ICEs. People know ICE. People use started calling as ICE vehicle, ICE vehicle, internal combustion engine. It can be petrol driven, or it can be gas driven, LPG and CNG kind of thing, or it can be diesel driven, right? These are all called IC engine vehicle. Now we are going to compare that with all the electric vehicle. So what are all the features, what are all the benefits, how it is achieved, all that we will discuss now. So if you take this example, this is a gasoline. Gasoline is nothing but a petrol, and you have the all electric vehicle. What's all electric vehicle means that it is a battery electric vehicle, not hybrid, not a plug-in hybrid, right? So if you take the IC engine vehicle, the important components, aggregates. So primarily this is the prime mover, what we call internal combustion engine. So those who are not familiar with automobile engineering, plus take any very basic engineering automobile book, you can get to know about it. Internal combustion engine. So combustion is happening internal to the engine. What is external combustion engine? Is steam engine. Steam, now you put a coal under this thing, firing will happen, that steam will go to the boiler, will produce the steam, and that is the other thing. So this is the internal combustion engine. Then we have the fuel system. Fueling system is there. Then you have a exhaust system. Then you have a fuel pump. There is a fuel tank, fuel filling facility, right? Then here you will have a thermal system, right? What are all the other thing you have? Thermal, right? Thermal management, cooling system. Then you will have a air intake system. Then HVAC, no, air conditioning and ventilation, HVAC system. All that are part of the current vehicle portfolio. Also, you will have a transmission system. So you have the clutch, gearbox, gear shift mechanism, all that, right? Then you have a connecting this one. If it is a front drive, it is connected like this, or if it is a rear drive, you have a propeller shaft, then center joint bearing, then rear axle. All this part of the transmission system. So as compared to that, it is having many rotating part, many actuation. Like you have a gear shift mechanism, you have a clutch mechanism, and all that. As compared to that, if you take a electric vehicle, so basic prime mover is a traction motor. This is what is giving the drive to the wheels. Traction motor. Traction motor is energized by a battery pack. Traction battery pack. So you have a battery pack which is giving the energy to the motor. So whenever the electric energy is supplied to the motor, it will start working. So how that is done? With the vehicle control system, you have the accelerator pedal. Then that is you are giving, I want to start the vehicle, I want to move the vehicle, I want to accelerate the vehicle, all that. So supporting that, you have a charging port. So how to this thing? The battery is only a storage device. As a fuel tank, it is a storage, right? So it is not produce any electricity. Then you have a external source. You have to plug in and get the grid power and charge the battery. Then you have the onboard charger. To facilitate that, you have a onboard charger. So interface is there. People are having a lot of domestic chargers are there. Then you have a auxiliary battery. This is like synonymous to a battery here, which is taking care of all the auxiliary requirement. Maybe a lighting, maybe a wiper, and all such thing, right? Then you have a thermal system cooling. So it can be cooled for motor. Then it can cool a battery pack, BTMS battery pack, and also the power electronic. Depending on the configuration, this thermal system will do. Of course, HVAC system is similar to what you have, but the drives and other things are different. Then you have a DC-DC converter, then you have a power electronics. All these are the aggregates. As compared to that, see the number of parts, right? Number of parts. For example, if you say 300 parts are there, here it is only one-fifth of that, one-sixth of uh, only 50 parts are there, because so many parts are removed, and because of that, the your maintenance and your attention to this thing, all that are there, less of a vibration, less of easy to maintain, right? All that are the benefit when you go for the electric vehicle. So here you have the what are all the losses. If you take a whatever the energy you give, internal combustion engine, 1 liter of diesel, 1 liter of petrol, then what is the calorific value? So what are all the losses? It is having several losses. Engine loss 68%, because the IC engine capable of giving delivery about 30% roughly, right? Remaining 70% where it's going is going as a waste heat through the cooling system. Heat is lost due to exhaust system, also frictional losses, right? Thermal such as radiator, exhaust, combination and pumping, frictional losses, all the thing. Then auxiliary electrical loss, idle loss, then drivetrain loss. You have every joint, every bearing, it is also having a lot of friction. It is also when you do the work is done, lot of heat is generated. It is also consumption of the energy. Power to the wheel is coming to 16 to 25%. So we give something, say for example, some X kilocalorie from the petrol. What you are getting to the output is only power to wheel is 16 to 25% only. But as compared to that, if you take a battery electric vehicle, the electric motor itself is very efficient, right? If you combine all the losses, then you have 4% accessory energy loss in battery charging. So whenever you do the charging, discharging, for this thing, there is a loss. Axle electric, ideal loss. You have a regenerative braking, which we will explain that later. It is a recuperation or waste heat recovery system. It is having a positive. It is not a loss. It is a plus. It is energy gained. Then if you see that electric drive system, motor itself is 90% efficient, but if you take all the transmission, the other parts and things like that, it is 20%. If you say even though it is 20%, this is if you deduct the gain, it's only net. So ultimately what you are giving, powertrain to the wheel 69%, plus you are getting 17%. The net benefit is that 86 to 90% is the total gain. So as compared to that, the electric vehicle is efficient in terms of the energy, efficient in terms of energy usage. Whatever you give as a 1 unit current, you are getting recovery to the work done to the extent of 86 to 90%. Whereas 1 liter equivalent this thing calorific value give is approximately, if you say that equivalent term in terms of if you calorie to electric unit to calorie, if you do that, this is only about 30%. If you say this thing, whatever the thing, X is the energy you are giving, for the same work done, this will consume only 30% energy. That is the biggest gain with the electric vehicle. So this is other parameter called well to wheel. So you get a what do you call uh, uh, from the well, oil well you are getting. From there it is extracted, then petroleum refinery, then petrol comes to petrol is the output that is transported. It's sent to the pump, then it is filled to the vehicle here, right? Then it is you are filling to the car, and you have lot of losses, even evaporation loss and so many things. Here, well to wheel efficiency is 13%. There we have seen in the vehicle, but if you take all additional factor, outside factor, this is the thing. So, similar way, if we have renewable energy, suppose you have solar, wind, all that, then transmission distribution loss 1 unit, delivery energy 18 minus 1, 17 unit. Then charging 2.5. Then useful energy, when you give 18 this thing, here you are giving useful energy is 13%. Here also you have the energy recuperation region where this is there. It is available for this, which is absent here. So it is a controlled explosion inside the engine, right? Then less inertia overcome the acceleration. Wasted energy, no energy recuperation. You are not getting any. Whenever you apply the brake, I will explain later. When I apply the brake, wheels are running, that is driven, that is driving the machine, electric machine, produces current. Otherwise, in a normal vehicle, it is going as a waste. Whenever you apply the brake, enormous amount of heat energy is produced. That is going as a waste to the atmosphere. So, mass distribution and wasted weight, right? Heavy drivetrain, because you have engine, transmission. Engine itself is very heavy as compared to an electric motor. The weight of the thing, vis-a-vis you compare, it's very this thing. Also, you have a lot of other components. You have a multi-speed gearbox, clutch system, clutch actuation system, and then you have lever mechanism, propulsion. All that are not available, not there in the electric vehicle. So, ICV is known for polluting the atmosphere because of exhaust gas and heat, CO2, this one, all the CO, your oxides of NOx, and you have the hydrocarbon and then particulate. All these are harmful for the society, for the human being. In terms of society environment, it's also called greenhouse gases. GHC, greenhouse gases, G, sorry, greenhouse gas. So these are all very harmful for the whole thing, GHC. In the electric vehicle, you are not having, right? Here, internal combustion engine, you can do in a this thing, 3 to 5 minutes, even 30 liter, 40 liter, whatever the petrol, diesel, you can fill it very easily. The range is also appropriately fueled. So, whatever the fuel tank size is there, how much fuel you are building, you are getting a good range depending on the vehicle model, fuel efficiency and other things. But you have frequent filling stations also available with you. So, if you take a battery electric vehicle, here there are multiple topologies there. Here you need not drive from take the mount the motor somewhere and connect all that. The wheel itself can be mounted. Wheel motors are there, hub motors are there. So directly you are mounting on the wheel. So that is the option. Smaller mass. Motor itself is very small, and if you have only instead of one motor, you can have even two motor, three motor like that, right? Conservation, it is a regenerative braking, right? Then most of the vehicle cost, the weight will be in the battery, right? The 50% of this one consumed with battery. Other than that, all the components are lightweighting, right? More space for the interior. So, a lot of space is vacated inside, and then by design, you are packaging the battery in the belly area, which is underneath the seat, right? There is no protrusion or something. Then you have lot of space. Then you have solar paneling. These are all options available. You can put a panel in the roof of the vehicle. Then that can, whenever the vehicle is uh, at the parking, at the sunlight or something like that, at the time it can charge the battery, right? So, no tailpipe emission. That is why it is called zero emission vehicles. This is what everybody is trying for. Zero emission on the tailpipe of the vehicle on the road. All the pollution, where vehicle is running, there only vehicle can pollute, right? We already seen that. And then you can this corona time, how the environment has become very clear because of vehicles are not moving. So, the specific energy of the diesel or gas is high, right? And then emit greenhouse gases. So, this is why concern we are switching. The you can refill as frequently as possible. You can have the good range. Short refilling time less than 5 minutes. Fuel tank takes relatively little space as compared to battery. Battery is a voluminous this thing and heavy weight, also costly. Higher maintenance cost because of so many moving parts. Brake energy not required. So all that you have the heat brake energy region is possible, energy recuperation, less of maintenance, battery pack, large space and weight and cost. Charging time, it is varying. So you have fast charging, 20 minutes, 30 minutes like that. And then you have the overnight charging, 8 hours. So you cannot use the vehicle when the vehicle is charged. That is also important. Travels, what is the range depending on the vehicle. Now the vehicles have come to the extent of 300 kilometer, 400, even now some vehicles have got 600 kilometer range. No tailpipe emission, no greenhouse gas, no GHG, low specific energy of the battery. That is why you are having a large pack, right? Internal combustion engine running cost is high today, real value, you know that. Also for India like country, it is also depending on the import, right? If you take electric, you need not import electricity. So it is domestically you can produce. Very poor energy efficiency, complex gearing system, noisy operation, refilling infrastructure is available. This is a positive point. Need to pick up speed to deliver maximum torque, right? Maximum torque is not available immediately. First, IC engine, you have a torque curve already, we have seen that. So it will start slowly, you have to use multiple gear at a low speed. Then as speeds pick up and then momentum is gained, then you can go to a higher gear. That higher gear will multiply the engine torque. Uses only hydrocarbon. You have to use only fossil fuel. It can be petrol, diesel, gas. Of course, we are having other thing like biofuel and all. Biofuel blend, all these are available here. So all that is true. Opposite, low running cost, uh, motor efficiency is 80%. Only one gear, simple gear train. This is basically to match speed of the motor to the speed of the wheel for given speed. It's very quiet, noisy. Noise is not there for the electric vehicle. It produces max torque right from zero speed. Technically, as soon as you start, the torque is available, right? You can get electricity from many sources, not only like fossil fuel. It can be solar power, wind power, hydroelectric power, or conventional nuclear power or thermal. But there are a lot of green energy option is very much available. So this is a comparison table. So it is electric, gasoline, hybrid, you have electric and gasoline, hybrid, sub-electric, right? Plug-in hybrid you need to plug in from the grid. Here electric is there, main is gasoline, right? But it will produce the electricity with the use of the generator inside the vehicle, motor and engine. Then CO2 emission, none, very positive. Here all negative. Then fuel facility, charging station, which is evolving, but you have many stations are there. available. Tax liability low, lot of subsidy, lot of promotion is available. That is not available for this, right? Here they are extending for hybrid also. Cruising distance short, this means for range. So long range, comparatively over the time, this will also getting improved. We have seen that green mobility, higher efficiency, dynamic performance, reliability, torque vectoring. I will explain that. Energy recuperation, regenerative braking, service and maintenance is easier. Right?